Let's begin. Today's December 16th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria cards 2, 9, 18, 19, 20, and 22, and the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A takes a look at our first digit, the triangle digit, and compares it to the number 3. So should the value of triangle be less than 3? Should it be equal to 3? Or should the value of triangle be greater than 3? Criteria card B will take a look at the 3-digit solution, and the Turing machine will let us know how many 3s there are. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card C will take a look at the 3 digits, triangle, square, and circle, add them up, and the Turing machine will let us know if the sum total is an even quantity or an odd quantity. Criteria card D will take a look at the first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should the sum be equal to 6? Or should the sum be greater than 6? Criteria card E will take a look at the 3 digits, and this time it'll let us know a little bit about its structure, so to speak. Specifically, there are 3 cases. One where the 3-digit code has no repetitions, as in the example 125, or the Turing machine can inform us that it's a double number, where there's a single digit repeated, as in the example 112, or it could be a triple number, a single digit repeated 3 times, as in the example 222. And finally, criteria card F will take a look at the 3 digits from triangle to square to circle, and the Turing machine will inform us a little bit about the ordering of the digits. Should the digits appear in an ascending order, meaning that they're increasing, as in the example 135, or should it be a descending solution, where the digits are decreasing, as in the example 421, or could it have no order? Let's take a look at the example of 231. Notice it goes from 2 to 3, it increases, but then it goes from 3 to 1, then decreases. Of course, you could also have a code that is decreasing and then increasing, but basically it's that shift from one direction to the other that can define a 3-digit code as having no order. Now, we've seen in previous puzzles where there's another case where if you have consecutive equal digits, that can also exhibit no order. So for example, if you take a look at the code 331, the fact that the 3s are equal and consecutive is an example of also a code exhibiting no order. And that's because when you go from 3 to 3, there is no increase or decrease. So for that fact, it exhibits no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to test is criteria card C. Okay, so the Turing machine does not approve of my proposal. We are adding up all 3 digits, so let's go ahead and do that. So 3 plus 1 is 4, 4 plus 4 is 8. 8 is an even quantity, but since the Turing machine does not agree with that, it's actually informing us that the sum total of our solution should actually be odd. So let's go ahead and type that up in our notes in section C. And again, we'll say that triangle plus square plus circle should be an odd quantity. Now, it may be a bit too early, but let's talk about that. So how can we get a 3-digit solution that its sum total is odd? Well, the most obvious case is that all 3 digits are odd. But you could have another case where if you have 2 evens and an odd, so if you add up those 2 evens, that sum is even. But if you add then that 3rd digit that is odd, that will give you a sum total that is odd. So we are looking at a possible solution that's either all odd or 2 evens and an odd. Next, let's go ahead and test criteria card D. Okay, so in this case, we are adding the first 2 digits. So if I add 3 plus 1, that is 4, and 4 is less than 6. Since the Turing Machine does not approve of that, that leaves us with 2 possibilities. Either the sum of the first 2 digits is equal to 6 or is greater than 6. So let's go ahead and type that up in our notes for section D, and we'll say that triangle plus square must be either equal to or be greater than 6. Well, as we discussed in the result from criteria card C, we could have a sum of 6 in triangle and square if they happen to be even. Now, we don't know if they are. You could still have a sum of 6 with 2 odds. That's always possible. And let's see. And then, of course, you have so many other options, but I don't think we can actually cross out anything because of that sum of 6. You could always add a 5 and a 1. Those are kind of our extreme cases. And then anything, any sum that's larger than 6, there are many, many examples of that. So I guess the question is, what would force triangle or square to be even? Is there anything that kind of stands out? Let's see. We also do have this case or this criteria card B that lets us know how many 3s there are. It would be interesting to note, let's see, as I described the all odd scenario. Well, let's also remind ourselves of the following 2 criteria cards, E and F. There have been other puzzles where we've solved, where we have deduced what E and F might be, and how they play off of each other. So we can say that if you look at criteria card F, we can say that the solution should have no order for the following reason. If you presume it's ascending, all the digits are increasing. That in itself implies that all the digits should be unique, meaning that there are no repetitions. So for that fact, if that were true, that would make criteria card E irrelevant because ascending would imply no repetitions, as would descending, just in the opposite direction. But all those digits would be uniquely smaller as you go from triangle to square to circle. So we can actually deduce that the solution should have no order. And we can make a similar argument in that if you have a triple number, well, that exhibits no order because there is no change from at least in this example, from 2 to 2 to 2, there is no change. It neither increases nor decreases. So that exhibits no order. And at the top of the video, when I was describing criteria card F, I did mention consecutive equal digits exhibiting no order, because again, there is no increase or decrease from, at least in this example, from 1 to 1. And so, and of course, if you had a double number where the middle was the different, well, that would be, either increasing and then decreasing or vice versa. So if you had a double number, that would also imply no order. So in those two cases, that would make criteria card F irrelevant. So we can deduce then that criteria card E, the solution has no repetitions. So we can deduce that the solution has no repetitions. Okay, so then we are uniquely looking for all distinct digits that have no order. So if it is to be an all odd solution, then you should have at least a single 3-digit. Again, you can't have 2 or 3 because they are unique. But if there is no 3, then that would mean that you are looking at 2 evens and an odd. But if the 3 is present, then we can safely say then it is an all odd solution. So let's go ahead, and luckily I do have a 3 in my proposal. So let's go ahead and test criteria card B. Okay, so it does not approve of the presence of 3. So there should not be a 3-digit. Very interesting. So let's type that up in our notes in section B, and we'll say that we'll deduce that the solution has no 3-digit. Okay, so again, if there is to be a 3, there can only be 1, but the Turing machine responded that it did not approve of the presence of 3. So in fact, there are no 3s. So we are able then to cross out all of the 3s in triangle, square, and circle, which means that we are looking at a solution that is that has 2 evens and then an odd, which might be 1 or 5. Okay. Well, this has been a very busy first round. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, comparing our first digit to the number 3. Obviously, we also know it can't be equal to 3, so it's got to be less than 3 or greater than 3. And it's still a bit outstanding as to what the sum of the first 2 digits might be, either equal to 6 or greater than 6. And we did announce that we are able to deduce that there should be no repetitions and no order. So let's take a look. So at this point, if we do have a sum of 6, it's not going to be using ones and 5s, because if you were to add a 1 and a 5, that gives you a sum that's 6. And then because of the no repetitions, that would mean circle would have to be even, and an even plus an even remains even though we're looking for an odd. So that means that if we do have a sum of 6, it's going to be 2 and 4 in triangle and square. And then what would happen to circle? Well, circle would have to be either 1 or 5, and more than likely criteria card F would play a part in deciding which one it might be. So if it is a sum of 6, that would mean that we would have triangle be an even. It would tell us which even it would choose, 2 or 4, forcing square to be the other even. And then based on the no order, that may lead us to believe what circle might be 1 or 5. So let's take a look. If triangle were less than 3, again, we're presuming that the sum is 6. So it may be something like 2, 4, and then the no order would then mean that we would have to pick a 1. Otherwise, if it was 4, it would be 4, 2, and then forcing us to pick 5. So we could have that, and so it would take, I guess, picking criteria card D to confirm the sum of 6, and then triangle would establish which of the 2 evens it might be. So, okay, so it just comes down to either 2, 4, 1 or 4, 2, 5. So let's go ahead and do 4, 2, 5 and see where that takes us. So just really quickly, there are no 3s in my proposal. The sum is odd. I'm proposing that it should be a sum of 6. And yeah, there are no repetitions, and there's no order. So it decreases then increases. All right, well, let's give that a try. Well, the whole reason was let's retest criteria card D and confirm that the sum is 6. Okay, yes, that is correct. So let's go ahead and cross out the greater than portion in our notes. And because we have a sum of 6, that does mean that there are no 1s and or 5s in triangle or square. So let's go ahead and cross out the 1s and 5s. And as I explained, the reason is you would be left with an even in circle, and that's just not going to be acceptable once we add them all up. So let's take a look. And so we probably are now going to test criteria card A and see what the even value in triangle might be. Okay, so it is true. So I did pick a triangle value of 4. 4 is greater than 3. Since the Turing Machine approves of that, then yes, it must be true that triangle should be greater than greater than 3. So let's go ahead and type that up in our notes. And again, we'll say that triangle is greater than 3. Again, that would make triangle 4. So let's go ahead and cross out the 2. And as a reminder, our sum is 6 and no duplicates. So that means that square cannot be a 4. So far we've got 4, 2. Again, no duplicates, so no 2 or 4. And so that leaves us with 1 or 5. And because of the no order, circle cannot be a 1. So it looks like our solution should be 4, 2, 5. So let's go ahead and type that up. And let's go verify. So let's see if 4, 2, 5 is the correct solution. Fantastic. Well, how did we do versus a Turing machine? Well, this is a 6 criteria card puzzle, and we did exactly 5 tests, so that's always great. We did do BCD in the first round, all incorrect, and then we did AD in the second round. D was repeated, and we outright deduced E and F. So let's go ahead and type that up. And again, that was BCD in the first round, all incorrect. We did test A, that was correct, and D, we got the good second round proposal and outright deduced E and F. Okay, wow, fantastic. So we beat the Turing Machine by 2 questions. So again, you know, as if you've listened to the videos in the past, you've known that we are beginning to use this these deductions between criteria cards E and F, how they play against each other, where we can deduce that there are no repetitions and no order. So obviously that really played out in a big way in this puzzle. And then also testing criteria card D. It is one of those criteria cards that has 3 possibilities. So we were able to take advantage of that, testing it in the first round, and then refining our proposal. And it did come out true that the sum of the first 2 were 2 and 4. And of course, it all started off with criteria card C, where we basically, once we found out that the sum was odd, just thinking of what possibilities could occur, knowing that the sum total is odd. Well, what about you? How did you solve it? Did you find anything interesting in your choices of criteria cards that you'd like to share? Please add those thoughts to the comments. If you did like the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.